All right, so now we learn about slopes, and slopes are going to come into play with what we're doing today. You guys mentioned it yesterday. As soon as I mentioned slopes, somebody rattled something off. Do you remember what you rattled off when I said this, y equals mx plus b? So that's what we're going to talk about today, all right? And that is an equation of a line, all right? We're not going to get to it just yet. We'll get to it in a couple minutes, okay? But before we do the y equals mx plus b, we're going to learn, let's see, I think we learned 3 in here. Do we learn point slope? Where do I teach point slope? Well, I don't show you the third one in this. We just do it a different way. Yeah. Maybe I'll show you another equation that I don't have in my notes, but we'll see. All right, let's do the first one. The first one is called standard form. It's probably the least, I was going to say useful. What word am I trying to think of? No? It's the most practical, I guess. I don't think that's the word I was thinking of. But anyway, that's a good word, though. It's probably the least practical out of the ones we're going to do. But it's still a form. It's the standard form of an equation of a line. Oops, kind of a mouthful of a line. All right, and here it is. I'll explain what it means in just a second, but just write it down right now. Remember seeing this in Algebra 1? Yeah, kind of, I don't know. It's been so many years since I've taught Algebra 1, so I don't remember what's in an Algebra 1 book, to tell you the truth. What you cover, what you don't. But we're going to talk about it here. And 0. ax plus by plus c equals 0. I don't think we're going to get too into it in this. Let me just check my notes again. Yeah, it doesn't even look like they're even going to ask you to write it in standard form. So I'm not even sure why they introduced standard form in this. Give me a sec. Let me look at it. I'm looking. Yeah, I kind of see what they're doing here. Let's keep that on hold for right now. Let's go to something else that we're going to apply this to. So what I want us to talk about is this. So what if I have a line? Let's make that line a different color. And I don't know, let's have it go through like this. All right. There's a place where it hits. There's actually two places where it hits the axis. Do you remember what this horizontal axis is called? Yeah, this is the x-axis, and the vertical one is the y-axis. Okay. So just keep that in mind. So go back to red. Where does this line cross the y-axis? Well, it crosses where they intersect each other. Do you see that? See that red line in the y-axis? So right there, that's where it crosses the y-axis. We have a name for that. And we call that the y-intercept. Okay, it's the y-intercept. I-N-T-E-R, then sept, C-E-P-T. Because it's where it intersects the y-axis, but they use the word intercept. All right? What do you think they call this point right here? Yep, because that's where it crosses the x-axis. So that would be the x-intercept. And those are important points right here. All right? Let's just say this goes up to 1 and this goes over to 1. What would that actual point be? That's -1. That's +1. I know it's a little ugly writing in here. right? So this point right here goes over to -1. This one goes up to +1. What would the x-intercept, what would the actual point of the x-intercept be? -1, 0. -1, 0, right? Because to label a point, you got to have an x and a y, right? So there it is, -1, 0. All right, what would the y-intercept? Again, it's kind of...
Vicky, to the office, please. Vicky, to the office. And if you're part of the praise and worship team, you have practice in the sanctuary now. Thank you.
During my class? What? Are you guys in the praise and worship team? Nobody? All right, so that's a 1 right there. Okay, so what is the x-intercept? Just got rid of that. What's that? You can answer my question or you got to go to the bathroom? Of course. Right in the middle of my great lecture here. Can't wait? Okay, if you can wait, then wait. All right, if you can't, then I'll let you go. But if you can wait, wait. All right, what about this point right here? Where is that point? 0, 1. Good. 0, 1. Everybody watch that? Everybody see it? Okay, the reason I did that is because of this. Let's put it in a different color so it doesn't all blend in. Notice the x-intercept. I'll just write over here. The x-intercept. I'll just put INT for intercept. Is that all right? All right, the x-intercept. What is 0 on the x-intercept? Which one? Is the x or the y? The y is 0, isn't it? On the x-intercept, the y is equal to 0. Everybody see that? What about the y-intercept? What's 0 on the y-intercept? It's the x. All right, so the x is equal to 0. So anytime you're asked to find the x-intercept, what you're going to do is you're going to set the y equal to 0. This is kind of where this comes into play right here. All right. So, and that's what they're going to ask you. They're going to ask you to find, actually, yeah, you're going to use the x and y-intercept in order to graph this. It's very simple. So what if they gave it to you? They're not going to give it to you. You're going to have to find it. You're going to have to do a little work to find it. But let's just make it super, super easy. What if I told you that the x-intercept was, I don't know, 3, 0. And I told you that the y-intercept was 0, -2. And I asked you to graph that line. All right? So let me make another graph here. Okay, and it's in yellow, so I'll put it in yellow. All right, so what do? We just plot those 2 points, right? All right, so to find the x-intercept, what does this really mean? It just means it hits the x-intercept or the x-axis at what point? 3, 0. So 1, 2, 3. So that's the x-intercept. That's where my graph is going to hit the x-axis. Where does it hit the y-axis? Hit -2 on the x-axis, right there. So how would I graph it now? Yeah, just make a line that connects the 2 points. Exactly. So make a line here, extend it. Don't stop and start at the 2 points. Always extend it through. Just looks a little nicer that way. Put your line, because it's a line, and there you go. You just graphed it. So if they give you the x-intercept and they give you the y-intercept, it's very, very easy to graph. Agreed? You put the 2 points there, connect them, make a line, and there's your graph. No big deal. But it's not always going to be that easy. Sometimes they're not going to always just give you the x-intercept and the y-intercept. That would be too easy. So sometimes they ask you to find the x-intercept and the y-intercept, but they have an equation of a line. Well, we learned the standard form. The way they write the problem is not technically in standard form, but it's kind of close. All right, so let's do the example. So here's example 1. It says use x and y intercepts. Use, there we go, that's better. Use x and y intercepts to graph, and they're going to give you an equation. This is an equation of a line. And I tell you what, I'm going to write it in standard form since we wrote the standard form. They don't do that, but I'm going to. So this is what we're going to graph. We're going to graph 2x minus 3y plus 6 equals 0. Does that look like standard form? Yeah, there's your a and your x. So what is the a in this situation? Remember the ax plus by plus c? Yeah, the a is 2. What's the b? Negative 3. What's the c? What's the c? It's 6. The c is 6, okay? So I want to graph this thing. And that's what they're going to do a lot. Now, on this example, if you look in the book, it's actually 2x minus 3y equals negative 6, okay? But we're going to start with this. Just because I wanted it in standard form. Since they talked about standard form at the beginning, I just wanted to put this in standard form, okay? But you could write it like this. This is the way they give it to you in the book. So how would I get that 6 over to the other side? Just subtract it, right? Subtract the 6. That's your answer. Okay? Everybody got it? All right, so this is what we're going to graph. Now, before you knew anything about y equals mx plus b, and you probably learned that last year, right? Because you guys told me y equals mx plus b, so you must have learned it somewhere. We're going to graph it this way with an x and a y intercept. A lot of times we end up doing the y equals mx plus b. We will talk about it here in a minute, all right? But not right now. So what in the world do I do? How do I use the x and y intercepts to graph this thing? Remember the problem before where they told you what the x-intercept was and what the y-intercept was? It was very easy to graph. So how do I take this and find the x and the y-intercepts? Well, remember what we said? To find the x-intercept, what's equal to 0? The y is equal to 0. So let's do this. Let's find the x-intercept first. Okay, so what was 0 to find the x-intercept? What is it? Yeah, what question did I just ask? Oh, 0. Okay, yeah. So what was 0? The y is 0. Sometimes I ask it the other way. All right, I couldn't remember what I said. But absolutely. So what we're going to do is we are going to do this. We are going to set y equal to 0. See that? Because that's how we find the x-intercept, right? The y is always 0. All right, anywhere on the x-axis, the y is always 0 because you don't go up at all, do you, on the x-axis? So we set the y equal to 0. So in this equation right here, what are we going to do? Make this y into a what? Into a 0. All right, so let's do it. So I got 2x minus 3 times what? 0 equals negative 6. Yeah, exactly. I just did this for the first time. But you know, making that a 0 is going to make that a 0. So you could have just written 2x equals negative 6. I just wanted to see where that came from. I won't even put a minus 0 here, okay? But minus negative 3 times 0 is 0. You could put minus 0, but you don't really need to. So 2x equals what? Negative 6. Divide both sides by 2. What's x? It's negative 3. Now, what did I just find? The x-intercept. Let's write it as a point. Remember, we set the y equal to what? 0. And what's the x? Negative 3. So that's one of my points, okay? Because I want to graph this line. Do I just need one point to graph the line? No, how many do I need? I need 2. So how do I find the other one? What am I going to find? I'm going to find the what? The y-intercept. Good. You got it. Find the y-intercept. So you always set the other one, not the y, but you set the other one equal to 0, which is x. So I set the x equal to 0. Now I go back to this equation, and I'm going to rewrite that. How am I going to write that? 2 times what? 0, because the x is 0 this time, minus 3y equals negative 6. So let's solve for y. Do that in your head pretty easy, right? That's 0. Divide by negative 3. And what's y? Positive 2. But let's write it as an ordered pair. 0, 2. Good. So these are the 2 points right here that I'm going to graph. It's not my answer. Don't circle them. Because what do they ask you to do with this problem? Right, they ask you to graph it. That's what they want you to do here. Okay, so let's graph it. Doesn't have to be a big fancy graph. I'm going to do it in a different color though. You might not be able to do that, but that's okay. So 0, 2, where's that? 1, 2. That's the y-intercept, isn't it? Okay, negative 3, 0. 1, 2, 3. That's the x-intercept. And now you just connect them. Make sure it goes through them. Don't start it and stop it right on those points. I've had some people do that. Remember, this is a line. It's not a line segment. It's a line. And there's your graph right there. So if you're given an equation with x's and y's, okay, you should be able to find the x-intercept and the y-intercept. It's an easy way to graph. It really is. Okay, it's kind of a nice, simple way to do it. There's other ways to do it, all right, but this is a nice way to do it. And you're kind of using that standard form, aren't you? All right, you're kind of using it. They wrote it like this, but it's pretty close to that. Everybody okay with that? All right, what if I asked you, we just finished doing slope yesterday, so what if I asked you to find the slope of this line? Find the slope of this line. What is it? How do you find it? How do you find it? You could just count since we got the graph, right? Okay, you can go up and over, you can go down and over, right? Let's go down. So we go down 2, which is what? Well, no, we went down. If we're starting here, we went down, so it's negative 2. That's important. Can't just say I rise 2. Rise 2 would mean I'm up here. I'm not. Okay, I'm down here. And then I run what? Negative 3. So what's my slope? It's 2/3. Okay? So what we're going to do is we're going to introduce another formula, all right, an equation of a line that's got slope in it. And yeah, I didn't really go through like how we get to it. I'll just give it to you. You guys have already said it. I've said it several times today. What is it? Y equals what? Mx plus b. All right. Now, there's a couple things on here. We know what slope is. Slope is m, correct? So I could have put m equals this. Yeah? So if we know a slope and the b, what in the world is the b? The b is the y-intercept. Okay? It's the y-intercept. So this one is the slope. This one is the y-intercept. The other two, good question. This x and y right here, you could write that as an ordered pair, right? X and y. This x and y represents any point on the line. You hear me? This x and y right here represents any point that actually lies on that line. So whatever that point is, I don't even know what that point is, but if I put that point in for this, and then I put in the slope of 2/3 and I put the y-intercept as 2, then the two sides would equal each other. All right? I could put a point down here. I could put that x and y in for here and here. And if I did, and I made the slope 2/3 and the y-intercept 2, this would equal each other. All these points, every single point on this line, I could put in for x and y, and everything will equal. Okay? You're not going to have to worry about that too much, but there will be some problems where you're going to have to consider it and think about it. So it's good that you asked that question. All right. Now, we are going to do another example. And what we're going to do is we're going to put it into this form. We're going to make the equation y equals mx plus b. Sometimes they'll start with it in standard form. But what you're going to have to do is you're going to have to solve for y. How would I solve for y in this situation? Well, keep the y there, right? Get rid of the 2x. How would I get rid of the 2x? Forget the 0. What do I do with the 2x? How would I move this to the other side? How would I move 2x to the other side? What is it? Yeah, minus 2x, right. So I minus 2x, right? Get rid of the 6, so we minus 6. So what am I going to have over here on the left? Negative 2x minus 6. But then I got to do what? I got to get y by itself. I'll tell you what. I'm just going to copy this and then put it down here. And let's talk about it. Let's just do it right now. So let's get rid of this box. Let's get rid of this minus 6. We'll do that in a second. So let's just do it. I'm going to show you how it works out. Remember we said the slope's 2/3, correct? So I'm going to show you another way to get the slope just from this equation. All right? You didn't need the graph to be able to count down and over to the left to find the slope. All right? You didn't need the x and y intercepts. Okay, but you could have, right? 2 minus 0, 0 minus negative 3 still gives you 2/3 slope. But here's another way that you could find this. If I solve for y, check this out. What do? Subtract a 2x, right? Subtract a 2x. So I got negative 3y, and let's subtract a 6 right now as well. Equals, see that cancels, that cancels. What do we got? Negative 2x minus 6. Divide both sides by negative 3. Are you seeing anything? Check this out. That cancels. Y equals, what's negative 2 divided by negative 3? It's positive 2/3 what? X. And what's this going to be? Plus what? 2. So we took the standard form. That's the standard form right there. We solved for y, and boom, automatically, without graphing, without having to figure out the x and y intercepts, just solving for y gives us those two things that we wanted to know. All right? There's your what? That's your y-intercept. That's where that graph crossed the y-axis, didn't it? Okay? And it also tells you the what? The slope. Yeah, smart. How did I do it? It's right here. I subtracted a 2x from both sides. Right? Bring down the negative 3y. Well, I did two things in the same step. I subtracted a 2x, then I subtracted a 6. If you do that from 0, it's just what? Negative 2x minus 6. And then I divided by negative 3. You got to divide everything by negative 3. So I divided that by negative 3 and that by negative 3. Negative over negative is positive, 2/3 x. Negative 6 divided by negative 3 is plus 2, positive 2. Right? And this is full of information. This thing right here, could I just look at that equation and tell you what the slope and the y-intercept was? No. But this one, could I just look at it and tell you what the slope and y-intercept is? Absolutely. Now, we don't really find the x-intercept that often with this form. They could have made an equation with an x-intercept in there. They just didn't. I mean, they probably did, but we just don't use it very much, okay? We are more concerned about the y-intercept. Good question, though. Why don't we have an x-intercept? Well, there is an x-intercept, but you'd have to rewrite the equation a little bit. We're not going to do it because almost all the time we always do the y-intercept. Natalie? Well, it is rise over run. That's what we did. That's how we found the slope when we had the graph, right? There's your rise. It's a negative rise. There's your run. It's a negative run. So that was negative 2 over negative 3, which is positive 2/3. So we did the rise over run. But it's a lot easier, I think. You may not think so because it's algebra, but I think it's a lot easier just solving for y, and it tells you everything you need to know. And you could graph this, couldn't you? So let's graph this one from scratch. We've already graphed it once, but we did it with the x and y intercepts. Let's graph it with the slope-intercept form. I'll use red. All right? First thing I look at is the y-intercept. That's the first thing that I graph. So if they give you an equation in slope, this is called slope-intercept form. I'll write that down in a second. Let's write it down right now. Slope-intercept form. Put the form down here. All right? It's not much of a brain teaser to figure out why they called it this, is it? Because there's a slope and there's an intercept. It's the y-intercept, but it's the slope-intercept form. Y equals mx plus b. Okay? All right, let's go back to this. What if I just gave you this equation? What if I just gave you this right there, and I asked you to graph it? What would you do? Go ahead. Yep, go to the y-intercept first. So you go up 2, put a point. You got it. So you could rise positive 2 and run positive 3, or if you wanted to, you could have started at that y-intercept and done what? You could rise negative 2 and run negative 3, correct? And watch, it'll show up on the it'll still be on the same line. So if I go up 2 to the right 3, there that is. If I go down 2 and to the left 3, there that is. Check it out. They all lie on the same line, don't they? Natalie, question? This way? What do you mean this way? That would be a negative. This is positive right here. This is a positive slope, positive 2/3, right? Because from left to right, we're going up. If it was a negative slope, it would go like this, right? But this is a positive slope. Would you agree? That's what we talked about yesterday, right? If you're going up the hill from left to right, you're going positive. So this is a positive slope. Put the arrows. Oops. And that's how you graph something in slope-intercept form. All right. Do the y-intercept first. Uh-oh, there goes my. Gee whiz! Why does it do that? There we go. I don't know why. It just decided to do that now. So do the y-intercept first, and then do the what? The slope next. Okay. You don't have to put all 3 points there. You could have just gone up 2 to the right 3. It would still lined up exactly the way it did going the other way. If you wanted, you could go up 4 and then go to the right 6. Yeah. If you went up 4 and go over 6, guess what? It's going to line up right on that line because 4/6 is the same as 2/3. Everybody got that? Okay. Ready for another one? No. You should be super excited now because you've learned so much already. All right, here's example 3. It says, now this time, they don't ask you to graph it. They don't ask you to find the slope and y-intercept. What they're going to do is they're going to give you something, and they're going to ask you to write the equation of the line. All right, so let's write that down. Write an equation of a line now. As soon as they say that, write an equation of a line, what are you thinking? What are you thinking the form of the equation of a line is going to be? Not standard form, no. Slope-intercept form, right. They don't tell you what form to put it in, but if they just say write an equation of a line, put it in slope-intercept form. Okay, there may be some times where you want to change it to standard form. I don't think in this class they do that. That's an Algebra 2. That's more of an Algebra 2 thing. But I don't know. They might. Maybe I just forget. So the first thing, as soon as I see write an equation of a line, first thing that pops in my head is this. Okay? Let's finish up the question, though. Write an equation of a line that goes through a point, negative 5, 6, and has a slope, I'll put m equals negative 1/2. Now this point is not a y-intercept, is it? Because it doesn't have a 0, right, for the x. This is just some rando point, okay? It's just a random point on our line, but it has to lie on the line. It's not just a random point anywhere. It's a point that lies on our line. We kind of talked about this a little bit earlier. So that's what this represents. So this is an x, and that's a y. Agreed? All right. So remember we asked about what does that x and what does that y mean? It means any point on the line. Do we have a point on a line? Yeah, we got a point. They give us a point that lies on our line. Okay, so that means the negative 5 goes where the x is. The y goes where? Where the y is. The m, the negative 1/2, goes where the m is. And guess what we're going to solve? The b. We're going to find the y-intercept. Okay? So let's do it. Let's plug it in. What do we put in for the y? 6. Come on, marker. There we go. 6 equals m. They tell us the m. Negative 1/2 times x, which is, put a dot. Is that all right? Instead of parentheses, since I got a fraction right there. Negative 5. I'm going to put it over 1 as well, since I got a fraction here. Everybody okay with doing that? All right. And then plus what? B. And I don't know b. But I'm going to find it, though, because I got enough information now. Everything else is numbers except for the b. So now I just simplify this and solve for b. It's going to be a little bit ugly because of the fraction, but it's okay. We can work with fractions. Let's simplify this thing right here. Multiply that together. What do I get? 5 over 2. It's positive 5 over 2, right? Why is it positive? Because negative times negative, right? All right, multiply the top. 1 times 5 is 5. 2 times 1 is 2, so it's 5 over 2. One more step, and we got b by itself. Divide? Subtract what? Subtract 5 over 2. Don't say 2.5. Keep it improper. All right, it's a lot easier to work with an improper than it is a mixed number. I know, you were brainwashed when you were little kids. Every single time you had an improper fraction, what'd your teacher always make you do? Change it to a mixed number, didn't they? All right, and that's not bad. I'm not saying that's a bad thing. There's a lot of times that's very, very helpful, extremely helpful. But when we're doing algebra, we don't want mixed numbers, okay? Keep improper fractions. Improper fractions are perfectly fine, okay? So what are we going to do? Subtract 5 over 2. Then what do we have to do over here? Subtract 5 over 2. Everybody good? All right, this cancels. What do we have on the right side? B. Now, what are we going to do with this? Well, we're going to change 6 to what? Nah, well, yeah, technically, but we want a common denominator. So I'm going to make it 12 over 2. Okay? Everybody see that? We made that 6 into 12 over 2 minus 5 over 2. And then we subtract 7 over 2. Good. So that's our y-intercept. Now, remember what I said? It's perfectly fine to change improper fractions to mixed numbers at times. This is one of those times. If I wanted to graph this, but I don't want to. It doesn't ask me to graph it, does it? But what if I wanted to graph it? Yeah, I don't know where 7 over 2 is, but I do if I change it to a mixed number. I call it a mixed number, okay? That'd be what? 3, right, and a half? Yeah. But don't write that as our final answer. Keep the 7 over 2. So really, we're almost ready to write our answer. We don't have to do any more math, no more fractions, no more figuring. Okay, what do I have? I got a slope, and I have a what? A y-intercept. So can I now write the equation of the line? Yes. Okay, I keep the y, just a y, equals m. What is the m? Negative 1 over 2. Keep the x at x, so I just put the x right here. And then we figured out what the b is. What is the b? Now, I said don't use the 3.5. If we were to graph it, yeah, that would be helpful to know it's 3.5. But we're just going to write it 7 over 2. If you would have put 3.5 there, it would not be wrong. Okay, so I'm not saying it's wrong to write this as 3.5. You just don't need to. There's no reason to do it unless you're going to graph it. If you're going to graph it, you have to know that 7 over 2 is 3.5. That's what they're asking for right there. That's the answer. Why is that the answer? Because it says right away, an equation of a line. That's an equation of a line. It's got the slope, which they told you. So really, the only thing we had to find was what? The y-intercept. That's all we had to find. Okay? All right. On the lesson plans, I do have doing a part A and part B, and we're over at 10 after, right? Yeah, so we only got like 3 more minutes, so I'm not going to start anything new. as a good place to stop. And you do have an assignment. It's 3.5a, which is page 141 and 19. So it's page 140, 1 to 19, and it's section, what are we calling it? 3.5 what? A, because we will do some more after tomorrow. So there it is. It's in your lesson plans that I gave you yesterday, and that should be good. Does that make any sense at all, what I did today? Yeah. All right, well, that's it for today. We'll continue this tomorrow.